All right, so today we're looking at Newton's third law of motion. So this law states that for every action, there is an equal and opposite reaction. So, for every action, there's an equal and opposite reaction. This is basically saying that if here's a wall, here's me, if I push against this wall with 50 newtons of force, then the wall is going to push back at me also with 50 newtons of force. So the action was pushing in, and the reaction was the wall pushing back at me. This can happen, this is how birds fly. So you have a bird, do my best. That's not how birds work. Oh well, we're keeping with it. So a bird, it's beautifully drawn, I know. When it flaps its wings, it sends a force down at, I don't know, let's just use an arbitrary number like 30 newtons. So it's flapping its wings down at 30 newtons, and then it's making contact with the air. So the air is supplying the opposite reaction, pushing it back up at 30 newtons. So birds fly by flapping their wings and applying that pressure. There's also other aerodynamics that go into it, but that is the gist. For every action, there's an equal and opposite reaction. Another way we could look at this is, let's say I am in a pool, finally working off the icing I've been eating. I'm under the water, so I'm right here, and this is a frictionless environment. So I put my legs up against the wall, and I apply my 50 newtons of force to here. The wall is going to apply the equal and opposite reaction, so 50 newtons of force, and that's going to drive me forward. So, the important thing to remember, why does the wall not also get pushed away? Remember, our equation was force equals mass times acceleration. So, the reason the wall does not get pushed is because its mass is so much higher than mine. We're both applying 50 newtons, but I have much lower mass, so that's actually going to move me. It's not going to move this wall. So every action pushing into it has an equal and opposite reaction, it pushing back, forcing me forward under the water. I'm going to give you a visual aid to this in a video, and then we'll wrap it up. It's going to be a short video today. Okay, so every action has an equal and opposite reaction, Newton's third law of motion. So the best way that I can describe this is if I say I'm pushing on this wall, so I'm pushing into it, the reason that the wall isn't pushed right over, the reason that you feel strain on yourself is because the wall is applying the same amount of force right back at you. Now we look at the mass that I have as a person and the mass of this wall as it's tied into the rest of the building, and you see that it's going to take an extreme amount of force to make this budge at all. But since I have a much lower mass than the wall and the whole building, when I push into it, and the wall pushes back against me with the same amount of force, I'm the one that moves. Because my mass is lower, and force equals mass times acceleration. So, I'm applying however many newtons of force into the wall, and it's applying the exact same amount of force back into me in this direction. Better way I can show that, let's point that down. So, I get down on the floor, feet up against the wall, and I start pushing into the wall, and I move far away from it. So, I'm applying the force into the wall, But the wall is pushing back at me with the same amount of force, and since I have such a low mass compared to it, I'm the one that moves. Now, if we want an example of how you could possibly have one object of a low mass and another object of a high mass and then still affect each other, you have to look at friction. So friction would be a reason that I would move if I threw an object that was smaller. So imagine I'm out on a basketball court and I shoot a shot, right? Basketball. So I shoot a shot, I don't move because I have friction. My feet are on the ground and I don't move because that keeps me from moving. But if I was wearing roller skates and I shoot the same shot, the force of me pushing the ball away might send me backwards a little bit. That is because the force I applied to the ball was also pushed back into my hands, moving me. And since my friction was reduced because I was on wheels, that actually made me move. Every action has an equal and opposite reaction. All right, so pretty simple stuff. Every action has an equal and opposite reaction. Whatever you push into something, it's going to push right back out at you with the same amount of force. Your homework for tonight is just going to be a quick 5-question worksheet. And then tomorrow, so this is this week, I'll give you another page for that. So tonight, we have our last Newton law worksheet. Tomorrow, we're going to do a study guide and a Zoom call. And then Thursday, there's going to be a test. And this is once again going to be an open book test. And for the equations, I'll have the formula there on the page for you. So a test over speed through Newton's law. So this is our week. Tonight, just the worksheet. Tomorrow, I'll put out a study guide in the morning, and then at noon, we'll do a Zoom call over it, because I know I've been clashing with Mr. Ladwig's math class, so we'll separate those now. And then Thursday, we'll have a test over speed through Newton's third law, all the stuff we covered in between those. All right, good luck on the worksheet. I will talk to you tomorrow.